So now you know what AC is and how to go from AC to DC by not using a stupid single diode, but using a full bridge rectifier instead. So you may be wondering, okay, fair enough, but how do I do the opposite? Like going from DC to AC. Well, you use an inverter. So today I'm gonna tell you how inverter works. Well. Just let's clarify. I'm not gonna tell you how an inverter works. I'm gonna show you an oversimplified way of how an inverter works because in reality and practice that involves transistors like MOSFETs. So I'm not gonna talk about them because this is like classical stuff. So, how do you go from DC to AC? I suppose that you have a some kind of battery here with a positive and a negative, so it's outputting DC, and you wanna feed a load which I don't know requires AC for whatever reason. Now, how you're gonna do that? Well, you're gonna do that by using a combination of switches, which I'm gonna show you. So I'm gonna have another switch here, and then all the way down to my some kind of resistance which requires AC. Let's try something like, I don't know, a light bulb. Well, this is a very bad example, but I didn't know what else to say because it's a very bad example because light bulbs wouldn't actually notice whether you are using AC or DC because you know they can work both in AC and DC. But for this example, let's suppose that this one is just some kind of resistance that actually wants AC, and like a light bulb can work both in AC and DC, so AC is gonna be fine. Now we have additional two additional switches here, so it's a combination of four switches. We have another switch here and here. There we go. And I can go all the way back to my source now. Okay, I'm gonna call this switch 1, switch 2, switch 3, and switch 4. Now, we are in DC, so the current is actually flowing from one direction to the other, so it's flowing in from positive to negative in this way. Now, why do I have the switches? Well, because the idea is to open them and open and close them, open and close them, open and close them, either 50 or 60 times per second, depending on where you live. So if you want 50 times per second AC or 60 times per second AC, in order to basically make an AC conversion, and DC to AC conversion. So I'm gonna use two different colors, the green one and the red one, because I'm gonna show you how the current is gonna behave when I'm gonna close two switches and then the other two. So let's suppose that I'm gonna close switch 1 and switch 4, and I'm gonna leave switch 2 and switch 3 open. So the current, which is flowing in this direction, it's not gonna go here because the switch is open, so it's an open circuit. There's no current flowing here, so it's gonna go down here, and it is not going to flow here because this is open. So it's an open circuit. There is no current here as well. It's going to go through my load to my resistance, in this case to my light bulb, which requires AC. But as I said, it can work in both AC and DC. But in this case, I suppose that it needs AC, so it's going to go here. And then it's going to go down here. And then it's going to go all the way down back to the source. Like so. Now, what happens when I open S1 and S4 and I close S2 and S3 instead? Well, if I open those two and I close those two, then the current, which I'm gonna draw, is in DC in red, is actually gonna flow and go through here. It's not gonna go here because it's open, so it's gonna go through here and down here, and it's not gonna go down here because this one is open, so it's gonna go through my AC resistance, through my AC light bulb in this case, my AC appliance, whatever that is, and then it's gonna go down and finally back to the source. So the idea is to basically get those two, close them, and then open them, and then close them, and then open them. As I close them, those two are open. As I open those two are closed. So S1, S4 close, S2 and S3 are open. S1 and S4 open, S2 and S3 are closed. And if I do this for 50 or 60 times per second, then my light bulb is going to experience a current flowing in this direction and in this direction and in this direction and in this direction, which is very similar to an AC source. Now, the thing is that, well, and by the way, this is used, for instance, in solar panels, because unlike other sources, other energy sources, solar panels are actually outputting DC direct current. So for any meaningful things, since our outlets are actually need to output AC, then we would have to convert it to AC to make it useful. So we do something like that. Kind of. Oh, by the way, this is called an inverter. So this is an inverter. But this is not actually an inverter. The reason why at the very beginning of the video I said that I wasn't actually going to show you how an inverter works is that this is kind of an inverter, but there is a significant problem here. Those S1 and S4 and S2 and S3 those switches, those old-fashioned mechanical switches, are never ever going to be able to open and close 50 or 60 times per second. There is no way they're gonna be able to do that correctly and without any problem, even during a prolonged period of time. So instead of using those mechanical switches, they actually use transistor, so like MOSFETs. But they're really complicated. They're not so complicated, but I don't really want. This is a circuit analysis basis. I don't really want to talk about transistors because they're kind of an advanced level. They're generally introduced in advanced courses, not in basics. Well, you may actually probably you're gonna see them when you take your course at your electrical engineering course at university. Of course, you're gonna see them, but those videos that I'm posting are supposed to be for the very, very basic stuff, like the stuff that pretty much everybody should know and should be aware of. They're not intended to be, for you preparing for your exam. So I'm not gonna talk about transistors. I'm just gonna I'm just gonna stick, sorry, with those basic things. So yeah, this is kinda how an inverter works, but just keep in mind that a real inverter is gonna work with transistors. So that's pretty much it. Cheers and bye for now.